Hello, my name is Mastura binti Rabai from CS25540 and this project is from the course ITT440. Today I will present my project title Adaptive Hybrid Parallel Web Help Monitoring System. Now I will demonstrate how the system works. First, I run the URL generator script to create 5,000 URL. This. Next, go to the main program. Now I will explain the main program which is written in Python. This program is designed to check the status of multiple URL efficiently using different execution methods. At the beginning of the code, several libraries are imported. These libraries are essential for handling networking and performance measurement. Next, a global session is created using request session. This is important because it allows connection reuse, making the program much faster compared to creating a new connection for each request. An HTTP adapter is also configured to increase the number of connections for better performance. Next is the load URL function. The load URL function reads the URLs.txt file. It loads all URL into a list so they can be processed later. If the file is not found, the program will display an error message and exit. Next is the check URL function. This is the core function of the system. It sends an HTTP request using session head, measure response time, return the URL, status code, and time taken. If an error occurs, it returns fail. Next is the classified function. The classified function categorizes results based on response time. For example, for fast, it less than 0.2 seconds. For normal, less than 1 second. For slow, more than 1 second. And fail if request fail. This helps in analyzing performance more clearly. Next is the sequential function. This function processes URL one by one using a loop. It measures total execution time and prints the result. This method is simple but very slow because it does not use parallelism. Next is the trading version function. This function uses threadful executor to run multiple requests at the same time. It creates multiple threads to handle URL concurrently. Threading is very efficient for I/O tasks like network requests, which is why it performs the faster. Next is the multiprocessing function. This function uses multiple processes instead of threads. Each process runs independently using multiprocessing pool. Although it's allowed parallel execution, it introduces overhead, making it slower than threading for this type of task. Next is the compare function. This function displays the total execution time for each method. It helps users easily compare performance results. This is the main function. The main function controls the program. It loads URL, display a menu, allow the user to choose execution method, run selected function, and this makes the program interactive and user-friendly. Lastly, program execution. The program starts from if name equals main. This ensures the programs run correctly, especially when using multiprocessing. Next, I run the main program. The system displays a menu with several options. 1. Sequential, 2. Trading, 3. Multiprocessing, 4. Run all. I will choose Run all to compare all methods. The system starts processing the URL using each method.
A few minutes later.
After execution, the results show the time taken for each method. Sequential take around 3111.27 seconds, which is very slow. Trading takes about 30.44 seconds, making it the faster method. And lastly, multiprocessing takes around 371.37 seconds, which is faster than sequential but slower than trading. From this result, we can conclude that trading performed the best for this project. This is because URL checking is an I/O bound task and trading is more efficient for handling multiple network requests at the same time. Multiprocessing is less efficient here due to overhead from process creation. In conclusion, this project successfully demonstrates that parallel and concurrent programming significantly improve performance. Threading is the most suitable approach for web monitoring system. That's all from my demonstration. Thank you.
I just had to let you know you're